Morning. The lessons we have discussed about PCA, and you know that we are discussing few important topics from data mining, and we are framing these questions from Hannah and Kamber. Without any delay, let's start the class. Just a minute. So you can see PCA to last class में हमने discuss कर लिया था. PCA is a powerful dimensional reduction technique that transform high dimensional data into fewer meaningful components by maximizing the is a statistical technique that we use in machine learning and data science to estimate the properties of a just a minute, uh, data set by repeatedly sampling it. बूटस्ट्रैपिंग का मेन कॉन्सेप्ट यही होता है, हम रिपीटेडली क्या करते हैं, सैंपल करते हैं, ठीक है, data set को. So in that way, we try to estimate the properties of the data set. So it is useful, especially when we have limited data and want to understand the variability, accuracy, or confidence of a model. Okay. These 3 points are very important. We, when we want to understand variability, accuracy, or confidence of a model, we use this technique. Now, what does it mean? As I said that this is a sampling technique with replacement. This is a sampling technique with replacement where we randomly select data points from the original data set. The original data set से हम randomly data points को pick up करते हैं. Each selected value is put back into the data set. So it can be selected again in future row. So जो भी हम data put किया था, मतलब pick किया था, उसको फिर वापस हम data set में put back करते हैं, ताकि फ्यूचर में भी इनको वापस जब हम सिलेक्शन करेंगे वो भी आ सकते हैं, राइट. नाउ आइडिया क्या है, ए न्यू डेटा सेट कॉल्ड बूटस्ट्रैप सैंपल, ठीक है. ए न्यू डेटा सेट इज क्रिएटेड from the original data set multiple times to simulate the different possible data set, ठीक है. तो एक नया डेटा सेट बनाना जिसको हम बोलते हैं बूटस्ट्रैप सैंपल. आइडिया सिंपल है, हम रैंडमली डेटा पॉइंट सिलेक्ट करते हैं, वापस उसको पुट करते हैं, ठीक है. अब इसका फॉर्मूला जो है, क्या है फॉर्मूला जो हम यूज करेंगे, इसका फॉर्मूला है अप्रोक्सीमेशन फॉर लार्ज एन. जस्ट अ मिनट. that the probability that a data point is not selected. तो एक पॉइंट को सिलेक्ट नहीं करने का प्रोबेबिलिटी क्या होगा, प्रोबेबिलिटी नॉट सिलेक्टेड इज व्हाट, 1 - 1/n⁴ ये प्रोबेबिलिटी है. सिलेक्टेड होने का प्रोबेबिलिटी से हम 1/n माइनस कर दिए है, ठीक है, टू द पावर n. एंड फॉर लार्ज n व्हाट विल हैपन, this 1 - 1/n to the power n is almost equal to e to the power -1, and e to the power -1 is nothing but 0.368. The value for e to the power -1 is 0.368. So इसका मतलब क्या हो गया, ये तो फॉर्मूला आपको याद हो गया, 1 - 1/n⁴ इसी का ही हमने अप्रोक्सीमेशन निकाला, e to the power -1, sorry, and that is almost equal to 0.368. Now, what does it mean? Around 36.8% of data is not selected in bootstrap sample. 36.8% is not selected, and around 63.2% is selected. Are you getting my point? So, क्योंकि हमें ये मिला 0.368 not selected होने का, तो 36.8% not selected होता है, तो रिमेनिंग 63.2% डाटा सिलेक्ट होने का प्रोबेबिलिटी है. This selected portion forms the bootstrap sample, ठीक है. Is it clear? Now, what are the process? Suppose जो हम algorithm wise बोलेंगे, तो first step, start with the data set of size n, randomly select n samples with replacement, n samples लो उसमें से, but here क्या है, n samples with replacement. Some values may repeat and some are missing, right? The important point, repeat the process many times and use result to estimate the statistics. Simple example एक दिखा था, original data set ABCD है, and you have a taken a repeat हो सकता है, okay, C D, और इसमें से B missing है. So A appears twice, B is missing, and C and D appear once. Got my point? यहाँ पे B अब select नहीं हुआ है. Now real life का अगर बताएंगे तो bootstrapping is like drawing balls from a bag and putting them back after a straw. ओके, ड्रॉइंग बेल्स, बहुत सारे बॉल्स फ्रॉम ए बैग, एक बैग से तुम बॉल उठाओ, उसके बाद वापस हर एक ड्रॉ के बाद वापस तुम उस बॉल को बैग में रख दो. तो इससे क्या होगा, ये बहुत अच्छा मतलब वो है. सम आइटम्स विल रिपीट, जितना भी बॉल उठाओगे क्या होगा, कुछ तो रिपीट होगा. कुछ आइटम्स रिपीट हो सकता है, कुछ आइटम चूज ही नहीं हुआ, ऐसा हो सकता है. तो इसका एडवांटेज क्या है, वर्क्स विद स्मॉल डाटा सेट, दैट स्मॉल डाटा सेट के लिए परफेक्ट है. नो स्ट्रिक्ट स्टेटिस्टिकल एजम्पशन, कोई भी स्ट्रिक्ट स्टेटिस्टिकल यहाँ पे हम एज्यूम नहीं कर रहे हैं, ऐसा कुछ फॉर्मूला यूज नहीं कर रहे हैं. एक ही सिंपल, ये 1/-1/n⁴ दैट इज e⁻⁻⁻⁴ 0.6, ये इतना ही सही है. रिप ठीक है. उसके बाद क्या है एडवांटेज, हेल्प एस्टिमेट्स मॉडल एक्यूरेसी एंड यूजफुल इन मशीन लर्निंग एंड स्टैटिस्टिक्स. डिसएडवांटेज और लिमिटेशन की, यहाँ पे बायस डाटा रिपीट हो सकता है. ठीक है. तुम बॉल, सपोज तुम बैग से बॉल उठा रहे हो, ऐसा हो सकता है एक बॉल को तुम बार बार उठा सकते हो, उसका साइज, उसका डायमेंशन समझ में आ गया. ठीक है. तो इट कैन रिपीट द बायस डाटा, computationally expensive and depends heavily on the original dataset quality. ठीक है. तो bootstrapping is a powerful resampling technique that generates the multiple datasets from a single dataset using the sampling with replacement. The key result shows that approximately 0.368 of the data is not selected in each bootstrap sample, making it useful for estimating uncertainty and model performance. ठीक है. तो इससे ये तो है कि अप्रोक्सीमेटली 36.8% डाटा सिलेक्ट नहीं होता है हर एक सैंपल में. तो इट इज यूजफुल फॉर एस्टिमेटिंग अनसर्टेनिटी एंड मॉडल परफॉर्मेंस. That is okay. Then let's come to the next, feature selection method. In machine learning and data mining, datasets often contain many features. However, not all features are useful in prediction. Some may be irrelevant, some may be redundant, and some may be noisy. तो हमें ये सब features नहीं चाहिए होता है. We don't need this type of features, right? Which are irrelevant and redundant or noisy. So to improve the model function performance, we use what? Feature selection methods. Feature selection means choosing only the most important features for building a model. Now, why it is important? Because it improves the model accuracy, reduces overfitting, reduces computational time, and removes irrelevant data and improves interpretability. Okay. Now, main feature selection method, out of that, we have forward selection. So, okay, so forward selection is a step-by-step method where we start with an empty set of features, add one feature at a time, select a feature that improves the model performance the most. So forward selection उसमें से एक टेक्निक है. यहाँ पे हम empty set of features के साथ start करते हैं. This step is very important. We start with empty set, right? Then at the time we add one feature, right? And select the feature that improves the model performance the most. Now steps क्या है? Start with no features at all, that is empty model. Then test each feature individually, select the best performing features, add next best features and repeat until no improvement. तो क्या क्या है, पहले हमने कोई एक empty model ले लिया जिसमें कोई features नहीं है, हर एक feature को individually test किया, then we select the best performing features, then next best feature को add किया, repeat until no improvement. forward selection. Okay, इसका simple example. Suppose we have the features is income, education, experience. Forward selection first. Start with now. Nothing. Empty set. Right. Then we have added age with single feature. Then we have added income. Then education if it improves the model like that. तो इसका limitation ये है, it may ignore the interaction between the features and early decisions cannot be corrected. जो पहले आपने select कर लिया आप उसको change नहीं कर सकते. Right. So that is forward selection method, forward feature selection method, and where we always start with the empty feature set. Then we start adding one by one, which is the base feature and which improves the performance. Then we have backward selection. Okay, that is again a very important technique. Now, backward elimination is the opposite. We call it backward elimination. ना यहाँ पे हमने बोला था forward selection. Let me change the color. Forward selection. और यहाँ हम बोल रहे हैं इसको backward elimination. ये opposite है. ठीक है? Is the opposite approach of the forward selection. It starts with all features. ठीक है? पहले forward selection में empty set के साथ start हुआ था और यहाँ पे सारे features के साथ हमने start किया. Then we remove least important features one by steps. Start with all features. Train model. ठीक है? मॉडल को ट्रेन करेंगे. Removes least significant features. उसमें से सबसे जो least significant होगा feature उसको हम remove करेंगे. Then feature retrain करेंगे मॉडल को. Then repeat until the base subset remains. ये eliminate करते जाएंगे. ठीक है? So until we left with best subset. Right. So this is these are the steps. Simple example, like suppose we start with all of them: age, income, education, experience. Now out of this, suppose we don't want means in this case, education is say least useful feature. We remove this. Then suppose income is the least feature. We remove this like that. So why this backward elimination is better? It consider all the features. पहले क्या हुआ था, कुछ features जो बाकी रह गया, we have not selected, और जो पहले select किया उसको हम correct नहीं कर सकते हैं. But backward elimination में ऐसा नहीं है. So it considers all the features together, initially captures features interaction and more reliable selection. Comparison हम करेंगे. So forward, we have seen that we started with the empty set, while backward, we start with the full set. Forward, we are adding features. Backward, we're removing the features. Forward, it is very weak feature interaction, feature or feature based interactions. We can, but backward में it is strong. Reliability, forward वाला आपका lower है, backward वाला आपका higher है. Got it? So forward selection builds model step by step, while backward elimination starts full and simplifies the model. अब ये सबसे हमें समझ में आ गया कि backward elimination is the more reliable because it sees the complete feature interaction first. Real life example की बात करें तो suppose we want to predict the house price. Features are right size, location, age, distance to city. Right. We start with all of them. Then we remove unimportant or less important features like age. We keep only the strong predictors like size and location. Advantages ये है forward selection में it is simple, fast for small data set, right? And backward में it is more accurate, more reliable, considered full data set, starts set. Limitation, both methods are greedy, may not give the global based solution. It can be computationally expensive for the large data set, right? So feature selection improves the model performance by choosing one only important variables. Forward selection builds a model step by step, while backward elimination removes features from a full set. It because it considered full interactions between uh, features. So before removing the variable, so you can say that backward elimination is generally more reliable. I hope it is clear. Okay. The feature selection is very important. Let's come back to next question. Machine learning में से हमने लिए हैं K-means, clustering. Clustering we have discussed earlier also. Clustering means this is an unsupervised machine learning technique where we try to group the data based on their similarity or homogeneity. Then K-means clustering is one such important clustering technique known for its simplicity. Its objective function is this. Okay. J is equal to xi minus mu k square, where first you have to choose the k, assign the clusters, right? K means number of clusters. Then we need to assign data points to the nearest clusters. Then we update the centroid by taking the mean. Then data points again changes and push to the cluster with the nearest centroid. So this process will become means repeated until and unless we have no further movement of the centers data points, right? So this is one algorithm, very important K-means algorithm. Normally, you have to know the objective function. We try to minimize these objective functions. Okay. So this distance xi minus mu k is representing distance between that particular data point and the center of that cluster or centroid. So we try to minimize this distance. Then we have Silhouette score. What is Silhouette score? Those who are familiar with this term, no need to say that this is a very important term when we deal with clusterings or clustering related tasks. This is an important method used in cluster evaluation. It helps understand how well the data has been grouped into clusters, right? It tells whether the data point is correctly placed in its cluster or not. What is the meaning? Silhouette score means how close a point is to its own cluster and how far it is from other clusters. Got it? So what does the Silhouette score mean? Silhouette score means how close a point to its own cluster. एक point अपने clusters के कितने नजदीक है और बाकी cluster से कितना दूर है. How far it is from the other clusters. Right? So it has a formula that you have to know. It combines cohesion. Cohesion means within cluster. Cohesion means within cluster distance and separations mean between clusters. So it combines both of them. That's why it is very important. And formula is Silhouette is equal to bi minus ai divided by max of ai and bi. So here Si is the Silhouette score of any data point I. AI is the average distance of the data point I to another point in same cluster. तो बाकी सारे points का जो distance लेके average निकाल दिया हमने. So that is the average distance, and BI is the minimum average distance of point I to points in the nearest clusters. I hope it is clear. So Silhouette of any data point I is equal to bi minus ai divided by max of ai comma bi. Ai represent the average this distance of the point I to other points in the same cluster, and bi is the minimum average distance of point I to other points in the nearest different cluster. एक ai का मतलब है I से बाकी point का जो distance है उसका average, और बी आई का मतलब है मिनिमम जो एवरेज डिस्टेंस पॉइंट होगा आई से बाकी 2 पॉइंट्स इन द नियर, तो अलग डिफरेंट clusters, the points belonging to different clusters uh, are asked just so it means the minimum average distance of the point I to the points in the nearest different cluster. So अपने cluster का नहीं बाकी clusters का point से कितना मतलब अपने सारे points का distance निकाल के उसका average निकाल लिया और उसमें से minimum जो होगा वो होगा BI. Got it? So SI is equal to BI minus AI divided by max of AI minus by comma BI. So AI actually tells us how well the point fits inside its own cluster, and BI tells us how far it is from the nearest other clusters. Okay, AI tells us how well the point fits inside the cluster. Because AI क्या बता रहा है? It is the average distance of point I to the other points inside the same cluster. Inside the same cluster. Got it? While BI Baki said, BI tell us how far it is from the nearest other cluster. So what we need? We need AI value should be small because अपने cluster के अंदर distance कम होना चाहिए बाकी बाकी points जितने भी points हैं उनके साथ आसपास होना चाहिए तो the value of AI should be small. Are you getting my point? It should be small. While BI value that we calculate of that data point to other points. Other points means nearest cluster. That value should be high. ठीक है तो ये फॉर्मूला से आपको समझ में आएगा बी आई माइनस ए आई डिवाइडेड बाई मैक्स ऑफ ए आई बाई डिवाइडेड बाई बी आई राइट ए आई कम होना चाहिए बी आई ज्यादा होना चाहिए तब ये एस आई का वैल्यू ज्यादा होगा राइट सो रेंज ऑफ सिलहोते वैल्यू इज -1 to +1. Again, this is very important. Range of Silhouette score is -1 to 1. Interpretation है +1 its point is perfectly clustered. 0 means point is on the boundary and -1 means point is wrongly clustered. +1 means perfectly clustered. 0 means on the boundary that is overlapped and -1 is wrongly clustered. How we do that? For each data point, compute distance to same clusters, that is AI, then compute distance to the nearest other cluster, BI. We apply the formula. What is the formula of SI? SI is equal to BI minus AI divided by max of AI comma BI. Then we interpret the result. Say, example, suppose a student belongs to group A. Distance to same group the students, average निकाल के हमें मिला 2. Distance to the nearest other group 8. So 8 minus 2 divided by max of 8, that is 6 by 8. That is this is 0.75 क्योंकि 1 के पास है 1 के पास होना मतलब perfectly clusters, right? Perfectly clustered. So this means this is perfectly clusters. Visual interpretation, you can see same cluster close होना चाहिए good. Other clusters से दूर होना चाहिए राइट की आइडिया होना चाहिए क्या है की आइडिया होना चाहिए नहीं की आइडिया है हमारे पास हाई एआई होना चाहिए तो क्या होगा ये बैक क्लस्टरिंग होगा क्योंकि एक क्लस्टर के अंदर डिस्टेंस स्मॉल होना चाहिए बैक क्लस्टरिंग इनसाइड अ ग्रुप हाई बीआई का मतलब गुड सेपरेशन फ्रॉम अदर ग्रुप्स एडवांटेज ये है easy to interpret works for any clustering algorithm helps to choose best number of clusters and measures both cohesion and separation limitation ये है कि it is computationally expensive for large dataset. It is sensitive to distance matrix use. It is not suitable for very large scale clustering without optimization. Okay, real example, you can say in customer segmentation, group A, high spending customer, group B, medium spending customer. So Silhouette score will check if customers are correctly grouped or mixed. It will find out that whether this group A consisting of those customers which are high spending क्योंकि A वैल्यू ज्यादा होगा तो क्या होगा बट मिक्स नहीं है, ए वैल्यू कम होना चाहिए, बी वैल्यू ज्यादा होगा तो ये दोनों अच्छे से ग्रुप किया गया है. So similarity score is a powerful metric used to evaluate clustering quality. It measures how well a point fits into on cluster compared to other cluster. A value +1 represents that good clustering happens, and 0 means overlapping, and -1 means incorrect clustering. Again, I'm telling you the formula. Formula is very simple yet very powerful formula. SI is equal to, let me color in a different way, BI minus AI divided by max of AI comma BI, whereas SI is the Silhouette score of the data point I, and AI is the average distance of point I to other points in the same cluster, and BI means minimum average distance point of I to the points in the nearest clusters. And we take the values -1 to +1 of SI. So I hope that this is sufficient for today. Let me discuss the other things in the next class. And still, and if you have any problem, and do let me know. Right? Thank you.